Hi there again, my name is Vitaliy Danylyk and now I want to present my second presentation about my project called Detecting Items with the Biggest Visual Weight. In this presentation I'll talk more about how I developed the program and how it works. Well, we remember that every GUI design, graphic user interface design, is developed by UI and UX designers. UI is responsible for the look and UX is responsible for the ease of presentation. And if for UI just enough artistic skills, for UX you need to know what the user notice, predict user behavior, in short, have a lot of statistics. So UX is quite sophisticated task and I want to help designers make UX faster and better. With a good GUI design, according to UX, the design will be easy to understand, it will give the necessary information, and it will direct your eyes to the right place. So let's consider this slide as an example. At first we can notice the text issue. Because of its big size, it's bigger than others, so it has bigger visual weight. Then we see a little bit smaller text below. Left part of this text is less lighter, so our point of view will shift to the right. And by the way, there is an arrow that looks to the right, and we are used to look in the direction there where arrow looks. Then we see this text like one whole thing. There is rotated text on the left, and this shifts our point of view to the left, and there is the bold text here, but it's not enough to attract attention. So we start with first sentence and goes to the bottom. Also, this slide design directs us from top to the bottom. Well, the issue is UX and the solution is program that returns UX information that predicts user behavior according to statistics. And the easiest way to do it is artificial neural network. We can train it with our statistic and receive the results according to it. There is a lot of data on the internet, but it's very difficult to find the ones that we need. So we should make two programs. The first will be the main app. It will be able to predict UX information about design. And the second will be able to collect data from users and make statistics. Then that statistic will go to the first app, to the main app, and we'll have trained it. And then the main app will be able to give us the right results. So the more data we have, the better app works. So we should make these programs in web. Users will be able to reach my program without any installations and from any devices. And it gives us a few features for collecting data app. This app is a website, or it could be a plugin, or it could be in form of advertisement. So users, by discovering different websites, will be able to use my program and more data will be collected. Since to implement all this is a lot of work, first there will be the first version. And this first version includes only website. So how training process works in general. These users go to website, to this program, and this program has already includes lots of pictures, lots of GUI design pictures. They work with those pictures and the data is created. Then this data is passed to training, and after training the configuration file is created. This file consists of data about connections between neurons and this file is used by main app. That's the main idea. The picture come to program and we receive UX information. The eye journey through design, the area attention information, and the time to realize information. And this information visualize on input picture itself. So we have picture, then we have this, and this. And for the first version of my program, it will be included only this feature, only the area attention information. Like other programs with GUI, in the beginning we have only prototype to imagine how it should look like. This is prototype of training app, and there is a logo of app and canvas. And my program is this canvas. There appear different images after users click. When a user clicks on it, it means that a user selected this area as the area which has code user's eye first. And this data goes to database. So this is a prototype of main app. Its appearance is the same, but the functionality is different. So the main canvas here, by clicking on it, a user can upload own picture to see area with the biggest visual weight. And after uploading, the program visualizes information. You can see here. You can see circle, and the circle is a point of user view. And it's a point of the biggest visual weight according to statistic. Okay, what about work in process? This is work in process of main app, and we can divide this work in process on two sub-processes. The first is transformation, and as input we have picture, and this picture can have different size, and it means different number of pixels. These pixels are input neurons in neural network, so we have to make a few neural networks with different number of input neurons. Or we can transform this input image to new image with other size by scaling it, and we need only one neural network according to this transformed picture. But it's not the end. We can help neural network. We can use contrast filter. It results in less number of training iterations because neural network will be able to see shape edges better. And as a result, we have new processed picture. And the pixels of this picture go as input to neural network. And this is the second process, neural network process. We only need feed-forward algorithm here because our neural network is already clever. So we have input layer, then we have a few hidden layers. There are 4 hidden layers, and there are 800, 700, 600, and 500 neurons. And finally, we have 2 output neurons, x and y coordinates of result point. Such a big number of neurons means that this neural network is able to find hidden patterns. But here is in one moment. We know that pixel consists of 3 colors: red, green and blue. So it means that we need to increase number of input neurons multiplied by 3, but it leads to increased calculation power. We haven't got a lot of calculation power, for the first version we can add another filter, grayscale mode. So as input we can give value that says how white is pixel. 0 means black and white means and 1 means white. So that's an example. This is how user sees, and this is how program sees. We can see here a big number of pixels, and it's lots of colors, and this is white-black picture, and it's only 64 by 64 pixels. And this image, these pixels, is input pixels to our neural network. So let's consider working process of collection data application. User comes to web page and see picture, then clicks on it, and it means that the user selected the area user saw first. Then we need to save input and output data. So this image transforms to another image by transforming process from previous slide, and that's our input data. The output data is our click coordinate, and this input and output data is one row in database. So as for code, HTML, CSS and JS. For GUI, I use Canvas for visualize my program, and Canvas is controlled by JS. Also, JS controls neural network, and I use framework Brain.js for works with neural network, and PHP is responsible for works with data, for storing, creating data, for training and other functions. Well, it's time for a demo. Come on. So let's start with program for creating data. First, we can see that program tells us what we need to do. Click to highlight an area that has code URI first, and click on pointer to go to the next picture. So as I said, that this program collecting data. So we have some file, some database here, and it's empty now. So let's click here and image appears. And the main goal is to select the area that has the biggest visual weight, that attracts lots of attention, and we can click everywhere we want. And I click here because I saw this text first, and this file is still empty. And when I click here, when I click on pointer, it means that the work with this picture is done, and the new picture will appear. And when I click here, the data is created. So we can see new picture here, and here we can see the previous picture. We can see input data. Input data is our picture, and we can see output data. Output data is the coordinates of my click. And let's move on. I saw this picture, this picture inside picture first, and I click on it and I move on. Oh, I see this guy first, and because it has the biggest visual weight here, and it attracts lots of attention, and I can click here, I can click here, I can click here, but I better click on the center. So let's move. Here I saw this text first because it's bigger than other text, and because of it, it has the biggest visual weight. So I saw it first, so I click here and click here on pointer to move on, and so on. So during this process, this file becomes bigger and bigger, and we can see lots of data here. This data is the user's choice, and according to this data, the main app, the main program, will make the results. So let's go to the main program. First, we can see a loading screen. That's because our configuration file is very big. It consists lots of data about connections between neurons, and there are very big number of neurons in my neural network, so it needs some time to load. And then we can see that that program tells us what we need to do. Again, double click to add the image, and it's all. So we can click here and upload my design, my GUI design. And let's start with this. And after uploading, image appears, and appears a pointer, and that means that this area has the biggest visual weight, and this area attracts lots of attention according to statistic, according to this data. And we can upload another one. Let's upload this. We can see that pointer jumps to another place, and we can upload the same image like this, but rotated. So that's how it works. Here we go. So that's my project, detecting items with the biggest visual weight by Danylyk Vitaliy.